Okay, everyone, I am going to start the class. And is it clear whether the picture and voice both are clear? Then directly I will start the class. Good morning to all. Can I start? Anyone can type the message. Okay, good. Thank you for the response. Ashish, Sangeeta, Vishal, Alok. Right. Thank you to all. I am going to start the class. Thank you for the response. And if you will have any doubt, you can ask me in the middle. Okay. Right. Let us start. And today topic is the moment of force or the torque. Moment of force or the torque. And for this, what is moment of force and what is the torque? You know that, for example, this is a body. In order to move this body along a straight line, then you should apply force, right? That means when you will apply the force, the object will go in the straight line, right? Then in the rotation, this is in linear motion, straight line motion. But if you want to rotate the door, if you want to open the cap of the bottle, this is a bottle cap. When you want to open the bottle cap, how you will apply the force? And now, for example, when you want to open the tap, right? Then how you will apply the force? And here, when you want to open the door, right? These are all rotating now, right? When you will apply the force on the door, right, it will be rotates. We are applying the force on the door. This is a door, okay, and here we are applying the force on the door. And now when you want to open the bottle cap, it is rotating. And here the when you want to start the tap, it is rotating. When you want to open the door or close the door, at that moment also it is rotating. In these three cases you will apply the force, but simply the force cannot rotate. Then there is some term is there in the rotational motion. Every term is changing in the rotational motion. Previously we discussed the displacement will become angular displacement in the rotational motion, velocity become angular velocity, momentum become angular momentum, acceleration become angular acceleration. Like that, there is some other term instead of the force which rotates the object. That term is called as the torque. Okay, torque is the rotational analog of force. Okay, in the rotational motion, force is replaced with a term that is called as torque. In rotational motion, the force is replaced with a term, with a word that is torque. That means when you apply the torque on a object, then at that moment that object will be in rotational motion. Okay, and to maintain any object in the rotational motion, you should apply the torque. Okay, what is torque or what is the moment of force? There is a definition is there, that is the product of, the definition is the product of force and perpendicular distance of line of action of force, line of action of force from fixed point is called as torque or moment of force. This is the definition of the torque or the moment of force. I will give the formula for this and I will explain the clearly the definition. What I gave this one. Okay, you will understand at the moment. The torque is denoted with the tau. This is the symbol of tau. Okay, and the tau formula is the force into perpendicular distance of a force. Okay, the product of these two. Torque is the product of force, and one more is what? Perpendicular distance of line of action of force from fixed point. This we can simply be write as F into R perpendicular. This is the formula for the torque. Okay, R perpendicular, R perpendicular. Okay, R perpendicular we wrote like this. Now, if R perpendicular is 0, okay, torque is the rotational analog. Don't worry if you not understood the definition, I will explain. Rotational analog, rotational analog of force is torque. That means in rotational motion, the force is replaced with a word that is called as torque. And now let us see, according to the definition, we will see here. If you apply the for example, you see this figure. You see, I will explain the figure. This is a particle. Okay, you see, this is a particle P. P is a particle, and this particle is okay, connected with a thin rod to the origin. This is the origin. Okay, and the line joining the particle, this particle is fixed at the origin by using a thin rod, just like this. This is a particle. It is connected with a thin rod, and it is fixed at the middle. Okay, and now what I am doing it here. Now I am applying the force on this. The line joining the particle and origin is called as the position vector. The position vector is always towards the particle, from origin to particle. And I am applying the force this side. For example, the force is applied this side. This is the direction of the force. Force is applied along the x-axis. The angle between the force and position vector is considered as theta. And now what we have to do it here, we have to, according to the torque formula, force into perpendicular distance of the line of action of force from fixed point. What is the line of action of force? This is the line of action of force, line along which the force is applied. You see the cursor, you see the movement of a cursor. Here my cursor is explaining everything. Okay, this is the line of action of force. Force is applied along this line. Okay, this is the position vector. What is position vector? The line joining the particle and origin. This is the line joining the particle and origin is called as the position vector. This is the line of action of force. Means line along which the force is applied. Along which line force is applied. Force is applied this side. Now here, according to the mathematics, when angle is theta is at here, the here also angle will become theta. This is based on the mathematics. Okay, and now this will become, this origin is the fixed point here. Okay, from figure O is considered as a fixed point. Okay, and now from the fixed point, what we required here, the force is F. From the fixed point, I want to know the perpendicular distance. Okay, perpendicular distance of the line of action of force from fixed point. You see the line of action is like this there, line of action of force. Okay, and this is the origin. Origin is the fixed point. This is the fixed point, and this is the line of action of force. Its distance, perpendicular distance from fixed point is R perpendicular. This is the R perpendicular. This is line of action of force, and this is the fixed point. Perpendicular distance of line of action. ये वाला line of action है, उसका perpendicular distance from fixed point. Okay, fixed point is this one, origin. This is the perpendicular distance. Okay, right. Then how to find out the perpendicular distance from this figure? For example, this is O, and this we can consider as A. This is P. From OAP triangle, we can find out the perpendicular distance also. How? How we can find out it? From triangle you see, okay, triangle OAP triangle. Okay, from that sine theta, if you want to write, sine theta equal to opposite side. Opposite side is OA. Hypotenuse is OP. What is OA from the figure? R perpendicular, right? OP is what? R. Then from this R perpendicular is what you will get? R sine theta you will get. Okay, right? R sine theta is you will get. What is R actually? What is R? R is the distance of point P, distance of particle P from origin. Okay, that is the R. Now here torque formula, in this case the torque formula is what? Torque is equal to, we write as F into R perpendicular. But what is R perpendicular from the figure? R perpendicular from the figure, from equation 1 we got as R sin theta. Right, this is from equation 1. Now the torque we will get as tau, this we write as RF sin theta. Okay, and this we can also write like this: tau bar is equal to, in vector form we can write R bar cross F bar. This is the another formula for the torque in vector form. Okay, and the torque in vector form formula, this one. Why how you got this formula? Because we know A bar cross B bar formula, vector product, AB sin theta, right? N cap also there, but its value is only 1. Then A bar cross B bar is AB sin theta. Then RF sin theta we write as R bar cross F bar. What is R bar at here? Position vector. And what is F bar at here? Okay, what is F bar at here? F bar is the force. F bar is the force. Okay, and now this is the formula for the torque. What I will explain clearly what is actually torque in the practical case. Okay, torque formula is this one: R bar cross F bar are the force into perpendicular distance of line of action of force from fixed point. Okay, in the practical application and practically where the torque is there, and that I will explain now. So take the screenshot and note it. Okay, and you one thing you note that if I will explain the 1 hour class, okay, you will get only 3 or 4 screenshots that you should write on the same day. Okay, then you will get the notes. Now actually it is very difficult to read directly the textbook. Okay, physics textbook, once you can open NCERT book and you try to read it, it is very difficult for you to understand. Okay, that's why my notes is very easy. Okay, to understand. Okay, it will clear your concept. Okay, that's why on the same day you should write, and no need to read the NCERT book. You can refer the NCERT book for the only problems. Right, for the concept, no need to refer that. Right, and my notes is enough. Okay, I am giving the notes by combining the many reference books and NCERT book, and which is derivation is easy and which is comfortable for you, that I will give. If you read all the lines in my notes, no need to read the NCERT book. Remember it. Okay, I am taking the screenshot. You take the screenshot. I am going to erase these all things. Okay, let us start. And torque real life application I will give now. The torque real life application is that, for example, torque is the rotating force actually. If you apply the torque, then it will be rotates. Okay, torque rotates. If we apply the torque, then object will be rotates. I will give the real life application. Okay, for example, this is the door. One question I will ask for is, why door or window, okay, not opens when you apply the force at hinges. Okay, at hinges you are applying the force. Why it not opens? Okay, right. Then for this you see the diagram, one diagram. Okay, and this is a wall. It is a fixed wall. These are the hinges. Okay, and these two are said to be hinges. For the hinges we are connecting one door. This is the door. You see here, these two points are said to be hinges. Okay, these two are the hinges. This is the door. Okay, and these two are the hinges. Hinges are the fixed points. Okay, and they are the fixed points. Door is fixed to the frame. Okay, to the wall by using these hinges. Okay, and now what happens at here? I am applying the force at this point. Okay, I am applying the force at this point. Now this is the direction of the force. Okay, the force applied along a certain line. That force applied along a certain line, that line is called as the line of action of force. Force is applied at a line along a line, that is called as the line of action. Line of action of force. Okay, line of action of force. Force is applied along this direction. Now I want the perpendicular distance of this force from the fixed point. This is the fixed point, right? This is fixed point. This is fixed point. Now this is the point of action of force. This is the fixed point, and this is the distance of the point, line of action from the fixed point. Okay, this is the perpendicular distance. Now the torque we can write as F into torque we can write as, we know torque formula. What is that? Torque formula is force into perpendicular distance of the line of action of force from fixed point we write. This is the perpendicular distance. You see, 90 degree it will be there. Force is like this there, and perpendicular distance from the fixed point is like this there. Perpendicular distance from where to where you have to take. Perpendicular distance from where to where you have to take from fixed point to line of action. Line of action is like this there. Fixed point is this one. Line of action of force from fixed point. This is the perpendicular distance. Perpendicular distance of line of action. Line of action is at here from fixed point. This R is the perpendicular distance. Okay, R perpendicular. For example, if you apply the force at the hinges, if you apply the force at hinges, if you apply force at hinges, if you apply force at hinges, then what happens? Force is applied at here, hinges only fixed point, then perpendicular distance becomes 0. Perpendicular distance becomes 0. At the moment torque becomes 0, right? Torque 0 means actually the torque is the rotating force. कोई ऑब्जेक्ट स्ट्रेट लाइन में जाने के लिए हम लोग फोर्स अप्लाई करना होता है, रोटेट करने के लिए हम लोग टार्क अप्लाई करना होता है, मतलब रोटेटिंग फोर्स 0 हो जाएगा. रोटेटिंग फोर्स को हम लोग टार्क बोलते हैं, राइट? इन ऑर्डर टू मूव वन ऑब्जेक्ट इन द स्ट्रेट लाइन पाथ, in order to have in order to have yes, Alok is asking, is it necessary to have a fixed point? Yes, I will explain. If fixed point is not there, then it cannot rotate. Okay, right? And now I will explain that one. If fixed point is not there, if fixed point is not there, at the moment what happens? It will be moves in the straight line path instead of rotating. Instead of rotating, it will go in the straight line. Okay. For example, this is a pen. Okay, this is a pen. Okay, you take it as a pen. You fix at them. You hold the pen at one hand like this. You can hold it with your hand. Okay, and what you do? Ask the other friend to apply the force like this. Okay, at the moment this will be rotate, right? When you fix the pencil at one end and ask the other friend to apply the force, otherwise by using your other hand apply the force, then that will move in the circular path. That means if you fix one end, apply the force at the other end, at the moment that object will go in the circular path. Okay, rotational motion. We are discussing the rotational motion topic. That's why fixing is necessary. This is the fixed point and this is the line of action of force, and this is the perpendicular distance. You see, this angle is 90 degree. This perpendicular distance is said to be then the torque is equal to force into perpendicular distance formula you have to use. If, for example, is it necessary to apply the force perpendicularly? No, it is not necessary. You can also apply the force like this, and this is the R. Okay, and there is some angle between the R and F. This is R. Okay, this is the fixed point, and here I am applying the force like this on the pencil, and there is an angle between the force and distance, right? That is a theta. At that moment torque formula is Rf sin theta you have to use. That is nothing but tau bar is equal to R bar plus F bar. I said this one, right? That formula you have to use. If you apply the force perpendicularly, then we have to use torque is equal to force into perpendicular distance, right? Now torque is a rotating force. Torque is a rotating force. Now if you apply the force see the diagram. Why door not opens when you apply the force at hinges? These are the hinges you see. At hinges, if you apply the force, hinges only fixed point. Force also we are applying at the fixed point. Force fixed point the same. That's why there is no distance between them. R perpendicular distance 0. That's why when you substitute in this, you will get torque 0. Rotating force is 0. That's why it cannot rotate. Okay. For example, you have a spanner. This is a spanner. You have the two spanners, one spanner with longer arm, one spanner with shorter arm. But the why spanner with longer arms preferred than shorter arm? The spanner is used to open the nuts. Okay, are the bolts? Okay, are the to fix the bolts or the nuts? We will use the spanner, right? Why the spanner with longer arm? Longer arm preferred than shorter arm. Why? They are preferring the spanner with longer arm. Can anyone can answer? Okay, the spanner means I will give the spanner. This is a spanner. In Hindi, I think you will tell panar like this. Something. You see this. We want to rotate this nut. Okay. At the moment you are using this one. This is the spanner, right? Okay, and this is the fixed point now. This is fixed point now. This is fixed it here, and this is the arm. Okay, this is only arm, spanner arm. This is arm. Okay, this longer arm we will select instead of shorter arm. Okay, and this is, for example, you are applying the force like this. You want to rotate it. You are applying the force at here. This is the line of action of force. Line along which the force is applied. Its perpendicular distance from fixed point is this one. This is the perpendicular distance, right? If arm is longer, then the perpendicular distance is more. Is it right? When arm length is more, perpendicular distance is more, then at that moment automatically the torque will be increases, right? The torque is the rotating force. If rotating force is increased means then it can rotate easily, right? That means why spanner with longer arm is preferred? Longer arm means long length spanner is preferred than short length, right? R is more, right? Very good. Alok. The torque is the rotating force. Torque formula is force into perpendicular distance. Right? Force into perpendicular distance. Here the R is more in torque proportional to R at here. For a given force, if you select the longer arm, then the torque will be more. Right? Even you will apply the little force, it can rotate. But of shorter arm, if you will take with the shorter arm, then what happens? In order to rotate it, you have to apply the large amount of force, because this you cannot increase R, right? In order to increase the torque rotating force, you should apply the F more force you have to apply. That means you will strain more at here. If you use the spanner with shorter arm, you see when they want to open the tire frame of the tractor or the truck, when they want to open the tire puncture or any problem will comes in the tire, when they want to open the tire frame, at that moment they will use the spanner with very longer arm, because it is required the more force to rotate. Instead of applying the more force, right, person cannot able to apply increase the force up after certain extent, right? But when you use when he use the longer arm spanner, R increases. Then R increases when you will use the longer arm. When R is more, automatically the torque is more, right? Rotating force is more for the long spanner. Okay, for the long spanner, R is more. When R is more, then at the moment torque is more. Okay, when torque is more, then object can rotate easily. Okay, nut or bolt can rotate easily. To increase the torque, we use the to increase the torque, we use the spanner with longer arm. We use a spanner with a longer arm. Okay, right, good. Now this is about torque. I think you understood the torque. Torque is the product of force and perpendicular distance. If you apply the torque, it will rotates. Okay. Simply if you apply the force, for example, uh, you are not using the spanner. You are not using the spanner. Okay. You are not using the spanner. You want to rotate this nut. You want to rotate this nut. Okay. You want to open it with your naked hand. Direct you are applying the force to open the nut of the tire or any open the nut for certain machine or anything. Okay, right. At that moment, what happens? You want to remove the wheel nut. Okay, lorry nut you want to open. Then with your finger directly you applied the force. Can you tell? At that moment, why it is difficult to rotate? It cannot rotate, but when you will use the spanner, it can rotate. What is the reason? Here you are applying the force, but it is not rotating. What is the reason? Here also the same person, if you will use this, if you use the spanner, it is rotating. But direct, if he apply directly, if he rotates, it is not rotating. Can anyone give the reason why it is happens? No? Do it fast. I'm waiting for your reply. Why nut or bolt not opens directly with your direct hand instead of using the spanner? What is the reason? You are applying the force, large force, even it is not opens. Can anyone tell? Can anyone tell? It is easy answer, but nobody is replying. You write in chat box whatever you have the idea, whether it is wrong or right, it's not matter. Can anyone tell? In real life, when you want to open the nut direct with your direct hand, it is not opens. What is the reason? Why? Right. Here we are applying the force. Okay. And here, this nut only fixed. Right. This nut is only fixed point we can take. Right. And now the fixed point is this totally nut is fixed. This point you can take. Then the torque is equal to fixed point you may take the center. This is the perpendicular distance. But torque is equal to formula force into perpendicular distance. But the perpendicular distance is nearly zero. Fixed point is at the center, right? Fixed point is at the center. Or this R perpendicular nut is very small size. R perpendicular is very small. R perpendicular is very small means even R perpendicular is nearly zero. Then the torque nearly zero. Torque nearly zero means rotating force nearly zero. Rotating force is zero means it cannot rotate. When you use the spanner, R perpendicular is increasing. That's when the torque is increasing. Then it is rotates. Have you satisfied with my answer? No. Don't worry in the response while giving the response. You can give the response. Don't worry about others. Array, what they will feel, what these members feel. If I told wrong answer, then other member will feel. I will blame in front of my friends. Don't feel like that. Okay, in 21st century skills, whatever the answer, right or wrong, you should reply. Okay, that is the communication skills. Don't afraid about the others. Okay, they are not telling anything means okay, they are the audience. Okay, don't bother about the others. Don't bother about the others. Okay, those who are not, those who are giving the wrong answer, they are the better than those who not give the reply. Okay, because the response is important. In the even while when you will go for any company or job, and if you will keep the silence, then it will be difficult for you. You should say something, and then later if it is wrong, then you can tell, okay sir, sorry, and I expected, I thought in different way, that's why I was unable to answer. Like that you have to tell. Okay, right, I am going to continue. Right, and now I'm going to erase this, you take the screenshots. Next topic is a couple. First, we discussed about the torque. Next topic is the couple. What is couple? Couple is also denoted with the torque only. Couple is also one type of torque only. It is also rotating force. Couple is also rotating force. Okay, it is also rotates. It also rotates the objects. Okay. Now, what is the formula for the couple? Couple is the definition is the product of product of force and perpendicular distance between perpendicular distance between perpendicular distance between two forces is called as couple. Couple means here two forces acts, right? Couple means two forces acts. Then the couple formula is couple is equal to couple also denoted with the torque tau. Its formula is force into perpendicular distance of line of action of force nahi hai idhar. Perpendicular distance between two forces. Perpendicular distance between two forces. Previously, perpendicular distance of line of action of force from fixed point we took. But here, perpendicular distance between two forces we have to take. Okay. And where we will use this one? What is the unit of this torque or the couple? SI unit of torque or the couple? SI unit of torque or couple? What is the SI unit of the torque or couple? SI unit of torque or the couple is torque is the force into perpendicular distance. That is force unit is Newton and perpendicular distance unit is meter. Newton meter. Newton meter is the unit for the couple. Okay. And next, where you will apply in the real life couple. Okay, for example, you want to open the tap, you want to open the cap of bottle. At the moment, you will apply the two forces simultaneously. For example, this is a tap. You want to rotate this tap. Okay, you will up one force you will apply it here, and other force you will apply it here like this. These two forces are perpendicular to each other. These two forces simultaneously you will apply, and when you will apply these two forces, this tap will be rotate like this, and when the tap rotates, then water will comes, right? And this is a water tap, okay, above the water tap. Okay, then here there are two forces. There is some perpendicular distance between the two forces, that is R perpendicular. Then the torque formula we write is torque is equal to force into perpendicular distance between the two forces we have to take. Perpendicular distance between the two forces we have to take. Okay, uh, or otherwise we write like this. This is the fixed point, right? This is the fixed point. This is the fixed point. Two torques will be there here. This is R1 distance and this is R2 distance, and this total distance is R. Now torque, two torques will be there here. Couple is equal to two torques होता है. Means tau 1 plus tau 2. What is the first torque? Couple is equal. First torque is due to this force. F force we are applying it here. Its perpendicular distance from fixed point is R1. Then F R1 we write. Second torque is the another side force is F force. Its perpendicular distance from fixed point is R2. Then F R2 we write. Then the couple is equal to, okay, sum of the two forces, two torques. That is F R1 plus F R2. F is common, we will get R1 plus R2. Then the couple formula we will get is F into R, right? Couple is the product of force and R1 plus R2 is R. R is the perpendicular distance between the two forces. It is the distance between the two forces, right? R is R1 plus R2. Okay, right. Now this is about couple, and the next topic is the angular momentum. Next topic is angular momentum. What is angular momentum? Angular momentum is L. Angular momentum is L. Its definition is the It is the cross product of actually angular momentum is the another term for in the linear motion, one term, momentum is the product of mass and velocity. In the rotatory motion, momentum is replaced with angular momentum, राइट। कोई भी ऑब्जेक्ट रोटेटरी मोशन में होते तो उसको एंगुलर मोमेंटम होता है, ऑब्जेक्ट सीधा स्ट्रेट लाइन में जाते तो उसको लीनियर मोमेंटम होता है। द क्रॉस प्रोडक्ट ऑफ पोजीशन वेक्टर and position vector and linear momentum. Linear momentum is the P. Position vector is r bar. Okay, what is position vector? The line joining one particle and origin in the coordinate system is called as the position vector. This is a particle in the coordinate system. Coordinate system means xy, x axis, y axis is said to be coordinate system. And now this is the line joining the origin. Origin means this one, center, center of the coordinate system. It is a point of intersection of x axis and y axis is said to be origin. And this is a particle. Consider particle is at here. The line joining this particle and origin is called as the position vector. Okay, its direction is from origin to particle. Okay, head is towards the particle. Okay, and then linear momentum, the cross product of position vector and linear momentum. What is the linear momentum? Linear momentum is nothing but p. P is what? P is the product of mass and velocity. इन दोनों के बीच में क्रॉस प्रोडक्ट को हम लोग क्या बोलता है? एंगुलर मोमेंटम बोलते हैं। दिस इज कॉल्ड एज एंगुलर मोमेंटम। नाउ एंगुलर मोमेंटम फार्मूला इज L bar is equal to R bar cross P bar, and L is equal to, we write as RP sin theta. Remember this one. L is equal to RP sin theta. Theta is angle between R bar and P bar. Okay, we know formula, that is A bar cross B bar is equal to AB sin theta, vector product. In the previous topic we discussed. Okay, now I'm going to erase this and I will continue. Next, angular momentum continuation I am going to explain. That is angular momentum formula in the circular path I want to know. Okay, angular momentum in circular path. How to write angular momentum in circular path? Angular momentum in circular path I want. Circular path में angular momentum कैसे find out कर सकता है? तो उसके लिए for example एक electron of mass m moving along a circle of radius small r. इलेक्ट्रॉन आपको सर्कुलर पाथ में मूव करता है ना ऑर्बिट में, फॉर एग्जांपल इट्स रेडियस इज r. Okay, and now the one electron of mass m, it is moving along a orbit of radius small r with speed v. Okay, right, with speed v it is going, and here this is the direction of the velocity and its angular momentum I want. Angular momentum in circular path, how we can find out? Then further purpose, this is the fixed point. Okay, the O we can take as the fixed point. O is the fixed point. Okay, about O it is rotating. Okay, m mass of particle. Otherwise you can also assume like this. This is a small stone, and for this one rope is connected, one thread is connected, and the free end of the thread is O is in your hand. You are rotating in the circular path, right? In this moment, angular momentum formula is what? Angular momentum formula is RP sin theta, right? Okay, but from figure we write one thing. What we write from figure, right? P we write as mass into velocity. Okay, momentum. What is theta at here? R and P are perpendicular. That's why theta is 90 degree. These two conditions you substitute. How RP perpendicular? R is this one. Okay, this is the R. P and velocity both are along same direction. Remember it. Momentum and velocity are same direction because momentum is mass into velocity. Velocity in which direction it is there, momentum also in the same direction. That's why this is the direction of the velocity. Okay, velocity is along the tangent direction, and the momentum also in the same direction. Means velocity and momentum are same direction. This is the momentum direction. This is the r direction. Both are perpendicular, right? That's all. Perpendicular means theta is 90. To substitute in above equation, then Rp sine 90 you will get. Oh, I forgot to write the P formula. P is mv. Then angular momentum formula is mvr. Angular momentum formula is mvr in the circular path. R is the radius of the circle, v is the speed of the particle which is moving along the circle, m is the mass. And now, but we know v is equal to relation between the linear velocity and angular velocity. Do you know that v equal to r omega? Then angular momentum, another formula is you substitute here, then L is equal to m into r omega into r. Then you will get is m r square omega. These are the angular momentum formulas. What are the various formulas for the angular momentum? In vector form, we discussed about r bar cross p bar and rp sin theta. L is equal to formulas are rp sin theta. Okay, this is one formula we discussed. And but in circular path, the formula will changes like this MVR or MR square omega. This is the special case. In this theta is not there because in circular path theta will become 90 degree. Okay, this is about angular momentum. Angular momentum in circular path. Angular momentum means what? Once again, I am going to repeat. Okay, Suklal Gagrai once again. Clear नहीं देख रहा है. Right? Is it the problem for everyone? Alok, Suklal, Jaya, Anesh. Is it appearing clearly or not? You increase the clarity. You keep there is a right side third settings option will be there in the YouTube, right? You see, click on the screen. There are three dots are there. In that three dots, quality is there. In the quality, at least you keep the 240 or at least you keep the 360. 360, if you will keep 360p, you will get the full clarity. Okay. Right, I am going to repeat this angular momentum in circular path. Angular momentum formula is r bar cross p bar. R bar is the position vector and p bar is the momentum. एक ऑब्जेक्ट सर्कुलर पाथ में चल रहा है. सर्कुलर पाथ में चलने के समय में उसका मास m है. ऐसे सर्कुलर पाथ में जाता है. Right, this is a fixed point. About this fixed point, it is rotating, and its velocity is like this there. This is velocity, and momentum also along the same direction. Mass into velocity. Velocity and this momentum and the position vector. Position vector means line joining this particle and fixed point is said to be position vector. This is r. And now r and p are perpendicular from here. P is this side, r this side. Now we have the formula for the torque. Torque is equal to r bar. Sorry, not torque. We are discussing the angular momentum. What is the formula for the angular momentum? Rp sin theta. R bar cross p bar in vector form in magnitude rp sin theta. But theta is 90 degree in this case. P is mv, momentum formula mass into velocity. This you substituted here. This P is the linear momentum, L is the angular momentum. Linear momentum where you learned in the ninth class, you learned product of mass and velocity in the straight line motion we will use. Okay, don't confuse with these two terms. L is the angular momentum, P is the linear momentum. P formula mv, substitute r into mv sin theta you will get. But theta is 90, then L is equal to you will get as mvr, where v is equal to r omega you substitute. Then v is equal to r omega from where you got this formula you got in the yesterday. Yesterday relation between the linear velocity and angular velocity. V is equal to r omega you derived. Thus you substituted here in place of v, r omega is substituted. Then finally I am getting the mr square omega. There are two formulas for the angular momentum of body in circular path, that is mvr and mr square omega. You know that uh, Bohr's postulates, atomic structures, chemistry is there. Bohr's second postulate is there. Angular momentum of revolving electron is MVR. Angular momentum of revolving electron equal to integral multiple of h by 2 pi. Planck's constant. MVR is equal to h by 2 pi. Have you seen this formula? This is the Bohr's second postulate in atomic structure chapter. Okay. Next, more 10 minutes I will continue, and after that I will close this one. Okay. The next one is the 10 or 5 minutes I will continue. Relation between relation between tau and L. This is the previous final exam 3 marks question. Derive the relation between the torque and angular momentum. Relation between torque and angular momentum. Okay, we have to derive the relation between the torque and angular momentum. Angular momentum. Okay, right. How to derive the relation between the torque and angular momentum? This I will tell and I will close. Okay, right. Angular momentum formula is what you know? Angular momentum formula. Angular momentum formula is L bar is equal to R bar cross P bar we write. And differentiate on both sides with respect to time. Differentiate on both sides with respect to time. Differentiate on both sides with respect to time. When you will differentiate d by dt, we have to write dl by dt is equal to d by dt of R bar cross B bar we will write. Okay. And there is a formula d by dt we have to apply. Differentiation matlab d by dt we have to apply. Okay, dl by dt is equal to this we write here like this. First, once we have to differentiate r, dr by r by dt. In the mathematics, it is the differentiation. You will learn in the mathematics. First, d by dt you write r for the r. Later p you have to write like that only. Next, r bar ऐसे लिख के अभी p बार को d by dt करना होता है. dp bar by dt करना होता है, right? And dl by dt is equal to this dr by dt. R is the displacement. Displacement by time gives the velocity. Velocity into p bar is the momentum. Momentum we write as mass into velocity. Okay. Plus r bar into dp by dt is what? Rate of change of momentum. Newton second law. Right? Do you know Newton second law? F equal to dp by dt. Yes or no? dp by dt we write as f. That you will get f bar like this. Okay. I'm going to erase left side. Let us see here continuation. But v bar cross mv bar, what happens? This m is a constant mass we write outside. We write v bar cross v bar. And v bar cross v bar formula is what? I cap cross I cap is what? What is the value of I cap cross I cap? Same होते तो जीरो आता है. ऐसे v bar cross v bar भी जीरो आता है. कैसे आता है? V bar cross V bar formula होता है V into sin theta. Theta is angle between the V and V. V and V is the velocity angle is zero. Velocity same direction. Both are velocity. Sin zero value is zero. And finally zero you will get. That means this will become zero. What you are getting it here? In the next step we write here. Or dl by dt is equal to. What do you write? dl by dt is equal to On the right side, what is there? Okay, this we write 0 plus r bar cross f bar we write. Okay, then dl by dt is equal we got as r bar cross f bar. But what is r bar cross f bar? Do you know? Huh? Do you know? Bar indicates the vector, right? Bar indicate vector. Right side is what? Tau bar. It is a torque. Torque formula is na? Torque formula r bar cross f bar. What you got here finally? Finally, we got the formula tau is equal to dl by dt. Right? We got tau is equal dl by dt. This is the relation between the torque and angular momentum. It is the relation between torque and angular momentum. It is exactly similar to in the straight line motion torque का जगह force होता है, right? Linear momentum का जगह angular momentum होता है. Have you seen this formula? F is equal to dp by dt. Force is equal to rate of change of momentum. Then it is similar to torque is equal to dl by dt. This is the formula. It is the relation between the tau and angular momentum, right? Its derivation is important for the 3 marks. Okay, today's class is completed. If anyone not give the attendance, then you can give, and I am going to close.